Assalamualaikum my students, Arif sir here, welcoming you again to our unit of definite integrals. We have already defined several concepts that are present in this definite integral, but today we have a last topic, that is properties of definite integral. And I'm assured that you people will keep patience, because today we are going to complete this unit and perhaps it may be lengthy today. So the patience of everyone is required today. We have 5 to 10 properties that are on this definite integral, and we will solve them one by one. They are very helpful to find out some integrals. And the first one, that is, if we have an integral from a to b f of x dx, we can write that equal to a to b f of t dt. This is our first property. And in this property here, what happens, the variable x, we can change that into variable t over the interval a b. So we will prove it, but you have to write with me. So I will take the function f of x equals to a to f of x equal to integral of indefinite integral of f of x dx. This is my function. I am taking it f of x. Therefore, f of t, if I will substitute the value of x as t, what will I get? I will get here f of x, f of t, because the variable is x, we are substituting t, d of x, that is d of t. Now, I have to show this is equal to this, so I will prove my LHS is equal to the RHS. So I will take now here LHS, that is beta a to b, yes, that is a to b f of x, but we have taken this f of x as this, and it will be f of x over the interval a to b. And by the fundamental theorem of integral calculus, we know this is equal to f of b minus f of a. This is our first equation. Now RHS, will find out what is RHS now. We have RHS, that is equal to f of this a to b f of t dt. It will be equal to a to b, that is interval, but we know that this integral f of t dt, that is equal to f of t. So here it will be f of t, but what the interval of this a to b. By the fundamental theorem of integral calculus, this is equal to t, we have to give the value of t as b and this a, so it will come out as f of b minus f of a. Hence, from this first and second equation, we are getting LHS and RHS are same. Therefore, you write here from first and second, integral of a to b f of x dx, that is equal to a to b f of t dt. This is our first property. Second one, second property is very important, that is integral of a to b f of x dx, it is equal to minus times, if we will change this limiters, if we will change the lower limit to upper limit here, and this upper limit we will take it as lower limit f of x dx. What it means is, if we change the intervals from a to b to b to a, then the value of the integral is equal to the minus times the value of this integral. So I will prove it. This is very important. Just as posted, let f of x is equal to a to b f of x a to b f of x dx. Therefore, f of, therefore this minus f of x is equal to minus times a to b f of x dx. Now what is our LHS? That is this a to b f of x dx. It will be equal to a to b integral of f of x dx. We know we have taken that. You have to here right without this interval, is it? So here f of x we have that equal to this integral, we have that equal to f of x, but over the limit a to b, it will be by the fundamental theorem f of a b minus f of a. This is our first equation. Second one, RHS we will get here. RHS we have minus times a to b f of x dx. It is equal to, you check here, we have that equal to RHS, we have b to a f of x dx. That is equal to minus times b to a. What is that? That is equal to f of integral of f of x dx. We know that is equal to f of x, so it is minus times f of x over the integral of b to a. So by the fundamental theorem, it will be equal to minus into f of x. We have to put the value upper limit, that is a, minus this f of b. It will be equal to, when we multiply this minus, it will get, this one will get minus and this one will get, it is f of b minus f of a. Hence, from this second equation and this positive, we are getting LHS. This is equal to the RHS. This is my second property. You write down the third property, that is, the third property is just like beta this. If we have a function that is continuous from this a to b in this interval, so if I find the value of the function from this f of x, the integral of the function from f of this a to b f of x dx, the third property says it will be equal to, if we take any point that is between this a and b. For if we take point c, the third property says we can write this definite integral as, from this point a to c f of x dx. If we take a point between this a to b, between the interval, plus the integral from this c, from this c to this b f of x dx. This is very easy grammatically, and you can also analyze it like this. If we have this function, so x-axis and this is our y-axis, this is our origin, and if I take this as x is equal to a, this one as x is equal to b, and this one f of x, f of x. We know that this a to b f of x, a to b, from this point to this point f of x dx, it is actually the area, this area that is in this region. But now if I partition this AB, this point and this point, in the in this inside or in between, so if I divide it here, like here is my point x is equal to c. If I divide it and drawing this, we know that this integral a to b from this to this is the area of this one. But if I take now the interval from this to this, from this a to c, f of x dx, this will denote the area that is under this curve from this point to this point and bounded by this one and this RHS. So I am getting this area. But when I will add this area by this x is equal to c, from this x is equal to c to this point, the plus if I will add the area from this c to b f of x dx, I will get the area that is this one. So another curve this and this and this. So when I will add these two areas, I will get my area back, the whole area. That is the third property we have to prove. Property number third, a to b f of x dx is equal to a to c f of x dx plus c to b f of x dx, where we are taking this c between this a and b, where this a is less than c is less than b. So you write down this proof. Let again that f of x a to b f of x, not a to b, you just like this, f of x is equal to f of x dx. Therefore LHS is equal to, what is our LHS? That is a to b f of x. It is equal to a to b, the interval from a to b, but f of x we have that equal to f of x. It is from a to b, and it will be equal to, now by the fundamental form, it will be equal to f of this b minus f of a. This is my first equation. RHS is equal to, that is a to c f of x dx plus c to b f of x dx. It will be equal to, now f of x, we know that we have taken as f of x, but the interval is from a to c, plus this f of x dx we have taken as f of x, and the interval is from c to b. This will be equal to RHS now, f of x c to a. What is that? F of c by the fundamental thought, minus f of a, plus this one. This is f of, by the fundamental thought, f of b minus f of c. This is f of c plus here, this is minus f of c, so they will get cancelled, and I am getting here f of b minus f of a. From first and second, if you concentrate on these two equations, you are getting LHS is equal to RHS. That means this is equal to this. This is our third property. Now we are going for fourth one, and that is also very important property, because that is frequently getting used. That one is very good, and we are often using that property, and the property is like this. Fourth one, if we have an upper limit as 0 and higher limit, if we have a, I will take a. Lower limit if we have 0, and upper limit if we have a f of x dx. Then we can write this as 0 to a f of a minus x. This is our second property, fourth property. So we will prove it. It is very important. What this property asserts, it says that if we have a lower limit 0 and upper limit a, we can give the value of function from a 0 to a, but we can put the value of x as a minus x. the result will be same. So we will prove a minus x, a minus t, we will give a minus t. So what we will get? Dx is equal to minus dt. But here you check, we have x is equal to a minus t. Here in this integral, definite integral, we have the this limit as this lower limit as 0 and upper limit a. So, but these are the values of x is equal to x, both these. So we have the definite integral from x is equal to 0 and x is equal to a. Now we are changing this variable to t, to the parameter t. So we have to change these values also. So when this x is equal to this a 0, when this x is equal to 0, when x is equal to 0, what is the value of t at that time? T is equal to, here it is 0, now it will get t is equal to a. And when the value of this t, x is equal to a, the value of t is equal to now 0. So here it will be now I, or I will be equal to 0 to a, but we have changed that. So it will be from now, when x was 0, what is that time? T is equal to a. So here 0, we have variable t at that time a. But when we have variable this x as a, we have that t is equal to 0. So now f of x dx, so we can write f of x, we have given the value of x as a minus t, so it will be a minus t. But what we have here now, dt, dx, that is equal to minus dt, so we will write here minus dt. It will be equal to this minus, we will take as common, so it will be minus 0, a to 0, f of a minus t dt. So I equals to, now you check here, we know that the property, when we will change the limit, upper limit we will convert it to lower limit, and lower limit we will convert to upper limit. The sign of the integral changes. So we have here a, we will take it upper limit, so it will be 0 to a. We have minus here, but this one will, again we will change this interval, we will get again another minus, and then f of a minus t dt, and it will be equal to minus plus 0 to a f of a minus t dt. So here we are getting I, this interval, we are getting it equal to 0 to a f of a minus t dt. But by the first property, we know by that property that we can change the variable t in terms of x, the result will be same. So we can write this as 0 to a f of a minus x dx. Hence proved, यही करना था, prove this integral, this I equal to this. So this is all. Another property, fourth one. Now the fifth one is, sorry beta, we are making this lecture very fast only because we have a lot of properties today. The fifth one is like this. If we have an interval 0 to a f of x dx, it is equal to twice 0 to a divided by 2, 0 to a divided by 2 f of x dx, if f of a minus x is equal to f of x and it is equal to 0 if f of a minus x is equal to f minus f of x. This property states us that this integral a to 0 f of x dx is equal to twice a to the 0 to a divided by 2 f of x dx if this a minus x is equal to f of x, and if a minus x is minus times f of x, then we have this, the value of this integral 0. We will prove it. We will take this 0 to a f of x dx. By the third property, we know that if we have a point that is between this interval 0 to a, we can split this interval in terms of this from this point to this point and this point to this point. We know that this a divided by 2 is a point between this 0 and a. So we can now partition this interval as 0 to a divided by 2 and then a divided by 2 to a. Here it will be 0 to a divided by 2 f of x dx plus now integral of a divided by 2 to a f of x dx. Now we will let this integral as same, but we will change here. This x we will take as a minus t because we need here f of a minus t is equal. So we will try to make this as a function of a minus t. So we will put x is equal to a minus t in second integral. A minus t in second integral. So what will happen? We will get this dx is equal to minus dt, but we will also get here when this x is equal to a divided by 2 and x is equal to a divided by 2, we will get at that time t is equal to a divided by 2, t is equal to this a divided by, so that t is equal to at that time a divided by 2. But when this x is equal to a, we will get t as a minus a, that is 0. So here now I am getting a to this integral a to 0 f of x dx equals to 0 to a divided by 2 f of x dx plus this one. Now it becomes here plus integral of a to a divided by 2 to a, but a divided by 2 at that time we have value of t as again a divided by 2, and then we have this a, at that time the value of t is 0, then we have f of x, that is a minus t, and then dt, that is minus d. After here I hope you understood. We have now this a to 0 to a f of x dx, we are getting it equal to 0 to a divided by 2 f of x dx plus minus integral of a to divided by 2 0 f of a minus t d. So this will be equal to 0 to a divided by 2 f of x dx. We know by the first property, by the second property, that we can change this interval, this lower limit and upper limit, but the sign also changes. So when I will take this a divided to the upper limit, the sign will be plus now, and it will be come here as 0, and this one will be a divided by 2. But we know by the first property also that this integral, if we change the variable t into x, the result is same. So here it will be f of a minus x dx. Now, the theorem says this: if this f of a minus x is equal to f of x, f of a minus x is equal to f of x, then we have this. So we have here a to 0 f of x dx plus 0 to a divided by 2. If this is equal to f of x, so I can change this f of a minus 2 as f of x dx. This is first condition, but it is also equals to this 0 to a f of x dx plus this one, this f of a minus a, if it is minus f of x minus f of x 0 to a divided by 2. These two conditions are only when this f of x is equal to f of a minus x and f of x is equal to. So here this one and this one will get cancelled. So I am getting here this, these are same, these are twice 0 to a divided to f of x dx, when f of x is equal to f of a minus x, and also I am getting here 0 when x f of a minus x is equal to minus f of x. This is our fifth property. It is also very important. Sixth property is like this: 0 to 2a f of x dx is equal to 0 to a f of x dx plus you can prove it by yourself. I will tell you what you have to do. By the proof I am लिखूंगा by second part 0 to 2a f of x dx. You can write it. You can partition this interval 0 to a. We know that this a is between this 0 and 0 to a. You can partition by third property, so it will be equal to now 0 to a f of x dx plus from this integral a to this 2a f of x dx. Now again, this one you have done, you got, but here you have to make variation. So you can now put this value of x substitute in the second integral. First integral you have to let just we have done in the previous property, and this property in this integral you have to put this x as f of this x as you have to take it as 2a minus t, and then you will follow the same procedure, or at last you have to change this variable t into x. You will get the property. Now we have another property. The property is seventh one, and it is the 0 to 2a f of x dx is equal to 0 to 2a f of 2a minus x, same as the property number 5th, and it is also equal to twice 0 to a twice 0 to f of x dx. If this is equal to this, if and only if f of 2a minus x is equal to f of x, same as first, and if this is possible only if f of 2a minus x is equal to minus f of x. Same method you have to follow here also. You have to first apply the sixth property, and then you have to apply the property number fourth that we have done in the. So you will split it first, and you will do the same as I have done. Just you know that you can you can write it also. We know that this 0 to a 2a f of x by the sixth property it is equal to 0 to a f of x dx plus 0 to 2 this a to 2a f of 2a minus. This is our property. Now you can put here the values. Yes, this is our property. Yes, we have property this 0 to 2a. So you can substitute here the values. When this is your this f of 2a is your f of x, you will get here 0 to 2a f of x, that will be twice this, and that will be equal to this twice, and then you have this equals to this f of 2a minus x. This one will get cancelled out. This you will get 0. You will get twice f of x. So this is our by you can use simply another property, that is property number 8. This is very easy. You can do it. And we are getting the dearth of time, so we will try to state all the properties, and now you have to prove them by yourself. If anyone will not get them, you can approach me. But property number 8, that is 0 to a f of x dx z a x f of x dx is equal to a divided by 2 0 to a f of x dx if f of a minus x is equal to f of same property here you can apply if you have I equals to this 0 to a x f of x dx you can apply the property number second that is we can write is equal to 0 to a this a minus x f of a minus x dx. Now you can make the value of this f of a minus x f of x here and you will get the result. Property number 9th, that is this is very important, minus a to a f of x dx is equal to this thing twice 0 to a f of x dx and then it is equal to 0. This is equal to this thing if f of minus x is equal to f of x, if f of x f of minus x is equal to minus x. This is the very important property and it is based on even odd function. If we have a function f of x as even, then the value of this integral we are getting twice 0 to a f of x dx. But if the function is f of minus x is minus 10, that is if it is odd the function, then we are getting value 0 of this integral. You can do it by yourself. And the next property is same as the second property, that is a to b f of x dx it is equal to a to b f of a plus b minus x. You can again use the same formula. You can substitute this very value to t and you will get the result by. Now this is enough. You can do it. These were all about these properties. Now we will solve some integrals tomorrow and we will complete the unit tomorrow, inshallah. And this property you have to tell me whether you have done or not, because if you will not, if you cannot do them, I will show you again. Have a good time.